Good morning. Today's lesson is 1.2. Today we're going to be doing some prime factorization, our essential question. How do you write the prime factorization of a number? Let's unlock the problem. Secret codes are often used to send information over the internet. Many of these codes are based on very large numbers. For some codes, a computer must determine the prime factorization of these numbers to decode the information. The prime factorization of a number is the number written as a product of all of its prime numbers. So you got to remember the prime numbers. One way. The key for the code is based on a prime factorization of 180. Find the prime factorization of 180. You're going to choose any two factors whose product is 180. Then you're going to continue finding the factors until only the prime numbers are left. Remember, they cannot be divisible by anything other than themselves and 1. Use basic facts. Think, 10 times what number is equal to 180? Well, 10 times 18 is 180. So, when I do my tree, I'm going to take my line. They've already started it for me. On this side, I'm going to have 10, and on this side, I'm going to have 18. Now I'm going to break them apart. How do I break apart 10? Well, 2 times 5 is 10. 2 cannot be broken down any further. And personally, I would have just circled it here, but they brought it down. So I always circle the end of my tree, and then they're bringing it down again, and they're circling it because it cannot be brought down. It can't be broken apart anymore. So I like to circle, put a box around the end of my tree so that I know those are going to be in my code. Now we're doing the 18. So 6 times 3 is 18. 3 can't be broken down anymore, so they're just bringing it down to the bottom. Again, I usually just circle, put a square around it, whatever makes it easy for you to remember that that's the end of that tree. Now the only thing I have left is my 6. So 6 can be broken up into 2 and 3. And again, these are the end of my trees. When you do this, you want to put these in numerical order when you're breaking them out. It's just the easiest way to do it. So I have 2. I'm just going to cross it out when I write it so I remember. And I have another 2. And then I have a 3. And I have another 3. And then I have a 5. So 180 can be broken up into 2 times 2 times 3 times 3 times 5. So the prime factorization of 180 is 2 times 2 times 3 times 3 times 5. They want us to look at the divisibility rules. So if you think about 180 as even, anytime an even number, you always know it is divisible by 2, always. So if I wanted to start with 2 as my prime factorization, 2 times 90 is going to get me 180. So again, if we break it out, we have 180. And they just keep bringing this 2 down. Personally, I think that's confusing. I do this. I say 180, and I'm just going to do it my way. And I would put my 2 here, and I would circle it because it's done. And then on this side, I'd have my 90. So I'll do it their way too. Well, again, think about divisibility rules. 90 can be broken up into 2. And again, that's the end of my line. And 45. So we've got our 2 here, and again, they just keep bringing it all the way down. I like to stop it there so that I know it ends. So I have 45. Now 45, anytime a number ends in 5 or 0, you know that it can be divisible by 5. So 9 times 5 is 45. 5 is finished. So let's do. And then 9 can be done by 3 and 3, and that would be finished. However, I'm noticing here they want me to divide 45 by 3, which is fine. If I were to do that, 3 times 15 is 45. Again, it's the end of the road for the 3. And if I come over here, I have 15, and 15 can be broken up into 3 and 5. Notice I get the same exact answers here at the end. As long as you finish, doesn't matter which numbers you do because, many numbers have different multiples. As long as you finish it all the way out to the end of your tree, you're going to get the same answer. So you can see we got the same answer here. 2, 2, 3, 3, 5. 2, 2, 3, 3, 5. 2, 2, 3, 3, 5. But I did use different numbers to get there. Another way, we can use a ladder diagram. So the key for a code is based on the prime factorization of 140. If we find the prime factorization of 140, first we're going to choose a prime factor of 140, and then we're going to continue dividing by prime factors until the quotient is 1. So using the divisibility rule for 2, think 140 is even, so 140 divisible by 2 is 70, right? 140 divided by 2 is 70. So I've got my 2 there and my 7. 140 and 70. So then I think, so if I have 140 divided by 2, I get the 70. 70 divided by 7, I get the 10. 10 divided by, and since they already gave me a 2 here, I know it's going to be 5, because 10 divided by, so we're going to put 5. And then 2 divided by 2 is going to give me the 1, and now I'm down to its prime factorizations. So this would be like the bottom of my tree when I did it the tree way. So we have 2, and remember we have to do them in numerical order. We have another 2, and then we have a 5, and then we have a 7. So if I use the divisibility rule for 5, we're going to think the last digit is 0, so 140 is going to be divisible by 5, because anything that ends in a 0 is always divisible by 5. Okay, so 5 goes into 140 28 times, so I'm going to put my 28 here. 2 goes into 28 these 14 times. And then we can say 7 goes into the 14 2 times, so there's my 2 right there. And then 2 goes into 2 1 time. So now I'm left with my, so again, if I circle, I get the same thing. I get 2, 2, 5, and 7, because we don't need this one. All right, I think you might be more familiar with the factorization tree, because I know we did that in 5th grade. However, the other one might be a little bit new for you. So let's look at this. We have 18, and they have us dividing it into 6 and 3. So we're going to bring down our 3 at the end, and we're going to circle it. If you're like me and you want to just stop here at that 3, the first one, I'm fine with that. Then we have our 6, and we're going to break that into 2 and 3. Again, I always circle the bottom, so I know that is my numbers. So I have 2 times 3 times 3. So let's do 42. So 2 goes into 42 21 times. 3 goes into 21, and we've got our 7 times. And then 7 goes into 7 1 time. So our prime numbers are going to be 2, 3, and 7. 2, 3, and 7. Okay, I'm actually going to have you work together. I know that this concept here might be fairly new to you. I am going to be on the carpet. If you need any help, you can also work together as partners. You're going to finish the problems in the big book and then work on your homework book. And remember, you have the online Think Central as well. Good luck. And don't forget that I'm on the carpet if you need anything.